So the goal for today is to get some practice with coding interview questions. So what I'm going to do is I'm going to pose a question to you and I'm going to impose about a 15-minute time limit where you're not allowed to use a computer. You have to either write the best answer that you can on paper, or I'll also ask for anyone who'd like to come up and use the whiteboard to practice actual whiteboard programming. And that way, no judgment, we can just take a look at the different solution approaches. And we can also justify our solution approaches to say, what order are these going to run in? Do we think a better order exists? And then we'll talk about a few solutions to each problem. And the goal is to go through about 3 of them. So are we ready to get started? This is the final exam for the class with absolutely no bearing on your grade whatsoever. But I think that it's good practice. So these are all taken from the Cracking the Coding Interview book, which is also a book that I used to put together and make sure that my slides were complete. Quite a bit of the material from those slides was added based on the material that was in this book. This is one of the very few books that I think should be owned by every computer scientist because we all interview for jobs, most of us more than once. So it's just good material. There's good information about the actual interview process, like what I've gone over. And there are also 190 practice problems in here of frequently found interview questions. Yeah. So the first one is going to have to do with arrays and strings. A lot of these are on a more complicated side. I'm starting with the easiest questions they have. All right. So the first one is implement an algorithm to determine if a string has all unique characters. Lots of possible solutions to this. Think about efficiency. Don't just solve the problem as efficiently as you can. So this would be a method you're taking in as input a string, and you want to output as quickly as possible based on the length of that string.
Can you read the question again? Sorry.
Yeah, does that string have all unique characters? Does anyone want to come up and try to whiteboard their solution on the whiteboard? Yeah. That's perfectly okay if people don't want to. But I think it's good practice. It's good practice to have that visibility and that public facing code that you would have to do in an interview setting. Yeah. 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 Then just give it this. Practice problems that might show up on an interview. And having people do it on paper, because sometimes you are actually whiteboarding it rather than actually typing it in an IDE. So the first question is, write a method or implement an algorithm that determines if an input string has all unique characters. As you implement it, don't just try to solve it, try to think about an efficient solution as well as be able to justify its runtime. Yeah. Anyone think they have a solution ready? What's your running time of your solution?
It's far out, but, you know, I guess I could put it on board, but.
If you'd like to, you absolutely can. So definitely quadratic is a solution. Do we think there is a faster solution than quadratic? No. Yeah.
Yeah, President Armstrong.
It definitely is a learned technique. The hardest part for me is not writing like a second grader.
My shoulders are good enough.
Someone's throwing himself a party up.
We made it.
How's it going, Aaron?
Good. How could they? Terrible.
So we're doing interview practice problems where we're writing on paper or on whiteboards. The first one was to determine if an input string has all unique characters. So try to write a solution. Write the most efficient solution you can find and then be able to justify its running time, whether you think there might be a faster or better solution than the one that you implemented and why.
Anyone else have a solution they want to check?
Probably about as easy as interview questions get. So if this is a challenge or this is making you think really, really difficult or hard about this, then there's lots of practice that you can do to prepare for this. That does not mean you don't belong in this field. It absolutely just means that practice, 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 practice.
Just randomly.
Yeah. All right, so here is a solution. What do we think about this solution? Not linear. Definitely not linear. Looks like we have some nested loops. So we're using some kind of character array to split the string into its associated characters. We are then going through the string and comparing each character in the ith position to characters in the jth position. And if we find that they are,
Like it starts at one, right? 'Cause like,
yeah,
You have at least one of that, whatever that letter is in there, those three starting at. So if you find one more, you increment it to two, and then you
Yeah.
X, it counts two, and then you return false.
yeah,
But if you make it to the end of all of these loops, then you return the.
gotcha.
Yeah.
Thoughts?
Quick question,
Yeah.
does trim remove all instances of a character?
Trim removes white space, yeah,
Okay, and you can't trim a specific character, right?
right. You can only, so yeah, dot trim will take any string and say remove any spaces or tabs or new lines that are on either side of it.
Yeah, it's just leading and trim.
Yeah,
Space, not in the middle.
So when it's linear, do you have to use like a data structure like a gradient list or something like that? Is that what you're thinking? Because how do you build that thing
right.
and then do it then?
The key to the linear time approach is that characters are stored as ASCII values. So you make enough space to store every ASCII value. And then you're going to be looking at that table to say, every time that I add to that table, is the value that's there already one?
What do you do like a hash table?
It basically is like a hash table for characters. So you get capital A somewhere in your string, you put it in position 67.
Okay.
65.
This is just
65,
like a new approach. This is just like screen temperature or something. No.
Not necessarily, if you can justify why, this shows good problem solving. It shows that you understood the problem and were able to implement a solution to the problem. It's not the optimal solution, but it shows good ability to create nested loops, to be able to compare things to each other, that you know how to compare primitives.
How do you get access to the ASCII code? Like, is that?
It's, every character is actually stored as an integer. So you can just either cast it as an integer or store a character as an integer. So you would have an array list of type integer that is the ASCII code. And whenever you take out a character, so you would go from the string, you would say .char at and you do a single loop, go through, get the character at the 0th position, 1st position, 2nd position, 3rd position, return that, cast it as an integer, use that as the index into the structure.
Okay.
And then you would only have to check an if statement whenever you do that. So they would start out at count 0 for that entire list. And then as you fill that list, you're going to ask, is the value of that 1? If it's 1, this is the second instance of it, return false immediately. If you get all the way through the string, return true. There are multiple n log n solutions to this. The first one would be instantiate a data structure that we've talked about this quarter. Anyone know what that structure is that would allow us for an end login just with insertions? So that's a good guess.
Would it be a tree?
A tree would be an interesting way to go about it. You could probably do it with a tree. Yeah. You could have an end login tree approach. That would be a little bit more difficult to code than the structure that I'm thinking of. The easiest, fewest line solution that I can think of involves a set. And the reason that makes sense is sets don't store duplicates. So if you went through the string and inserted each character into a set, you could just return whether the size of the string and the number of elements in the set were the same or different. It's a really short, easy code solution that you could probably write if you do what you were doing from the start in under a minute. So if programmer's time is something that is important and you wanted to justify your solution saying, I want to be able to implement this as quickly as possible, this is the fewest line solution that I could think of, even though it runs in n log n time. The extra log n on top of the n is not going to be a huge factor. You could justify it that way. Another way that you could implement this is to sort the string in line by character. So you could just call these strings dot sort, which will sort the string by character permutation. Then you could look at the current character and compare it to the next character and see if those are ever the same. If they are, return false, otherwise return true. That would also be n log n.
I was writing down the sort function.
Yeah, you could use either merge sort or quick sort or a built-in sort. Don't reinvent the wheel in a programming interview. If you have access to a sort function, call the sort function. Don't write your own sort function. Yeah, counting sort would. We didn't talk about counting sort in here, but counting sort is an O of n sort. So technically you could use counting sort. Yeah. So that's the first one. Are we ready for the second problem? Do people feel like they have a couple ways to solve the problem in their back pocket now? You're unlikely to ever see exactly that problem again. So the question is, can you take these ideas, these structures and algorithms that we've talked about this quarter, and can you apply them to a problem we haven't seen before to say, oh, this is the right time to use this structure or this algorithmic technique? All right, this one is called check permutation. We're going to take in two strings and we want a single method to decide if one string is a permutation of the other string, which means that it's that's the same characters, but in a different order. Could be the same order. So are the characters in the first string equivalent to the characters in the second string in some order?
It's the best time you can get on.
We can also do linear.
Can you read the question?
Yeah, so we have two strings coming in. We want to check if one string is a permutation of the other. Which that's not directional. If one is a permutation of the other is a permutation of the first. I thought of this one too, but it's good to have you right here.
Would this count for duplicates?
Sorry,
Would this count for duplicates? So like, if there's
Yeah.
3 A's in one, 2 A's in the other, that's not.
that is not the same, right? So we want exactly the same character set. Yeah. really talked about it here, so I can't expect people to know it. I don't know if that would be. Dynamic programs for the problem. We're doing programming practice problems, and the current one that we're working on paper. Is we're taking in two strings into a method and we're determining if one string is a permutation of the other. Meaning that it has the exact same character types and counts, just in a different or same order. Cast in read and deer. You would get yes. Yeah, exactly. There's two ways that works. Read is in I read a book. Deer is in oh no, I killed a deer. Oh no, I hit a deer. There we go. That's better. What is that deer doing in the middle of the road? That's the. I should come up with, can I get an example of using this in a sentence for spelling bees? I would be so good at that. The candidate wouldn't be able to spell it, they'd be too busy laughing. Anyone have a solution? Couple people? Anyone want to write it on the board?
My handwriting sucks.
You want two solutions?
We can have two solutions up there, absolutely. If one of you can find the eraser, but there's open there, I know. Shape your color.
English not active. Make it careful. Okay, hold on. Is that one called?
Yep, cracking the code. Really good book. Highly recommend that everybody on a copy of this book.
One you are.
What is this?
Coding interview prep questions. Not allowed to use a computer, have to write it all on paper or on the whiteboard. We're comparing solutions and trying to figure out what the optimal solution to them are.
And then give them away for problems. Process.
Barge in every day.
Few times a quarter.
This is what happens when you have the power plan.
I've already graduated. You can't take my degree or my diploma away from me at this point.
You should do that. She does.
I'm her teacher.
This is why you barge into people whose classes you aren't in. Right. They're very similar. Set them to character arrays, sort them, and determine whether they're the same string. I like it. Yeah. Yeah, that will short case a lot of times when they aren't the same, and you don't want to actually go through the n log n process of sorting. So here we have a guarantee of merge sort as long as you've implemented merge sort. What is the runtime of the built-in dot sort in Java?
And love
n log n, it uses merge sort. Do you think there's a better solution to this? I gave away the answer to that earlier. There is a linear time solution. N log n is very good because it's very close to n. N log n is much closer to n than it is to n squared. So if you brute force this going character by character to verify something in an n squared time, that would be a highly inefficient solution because it's not really near n log n. But an n log n solution is very close to an n solution. What would the linear time solution look like? Does anyone have any ideas of what that might kind of look like? Some of the ideas that might be in that solution? How do you get this down to a single pass over these two strings?
I'm talking. The process and whiteboard is explain your process. If you explain the process and you're wrong, it's still better than not talking at all.
Very true.
Come on, guys.
Sure.
Taryn?
Or-
Come on, guys. You haven't saved me. I can start calling. Sometimes they're talking.
So with a single pass over this, how could we do that? What if we had access to that same ASCII array that we did in the last problem? How could you structure a solution around keeping track of character counts?
Could you just sum up the ASCIIs of both and see if they are the same?
That's a very intriguing idea. The issue is that you would have, as soon as you're summing it, you can have two different sets of numbers that sum to the same value. So you could have two different strings that are different that would sum to the same ASCII value, but that's a really clever way to think of the problem, because I don't think that that's necessarily particularly intuitive when you're looking at characters and thinking, I could think of these as numbers. What mathematical operations can I do to this? So that's really outside of the box thinking, that's great. So we have an ASCII array. What do we do to it? Would this work? Yes or no? If it works, great. If it doesn't work, tell me why. We're going to iterate over the characters of the first string, and we're going to go into this array of integers that represent the ASCII values of those characters, and we're going to increment each value for each character that we see. So now there's going to be a count of the ASCII values of the characters from the first string. Then we're going to take the second string and each of those characters, and we're going to go to each of those and decrement. As we decrement, we're going to check, is the value that's at this index in this ASCII array less than 0? If it is less than 0, we can already return and say, these are not a permutation of each other. If we get all the way to the end of this process with none of the array indices going negative, we return true, they're a permutation of each other. Does that work? Or are there flaws with it?
But how, I guess I just don't understand that.
So we have an array of 128 spaces,
Mhm.
each of which represents the unextended ASCII code for a particular character.
Mhm.
We're going to iterate character by character through the first string, and we're going to increment the value of the index that we find for that character. So if this is, the string is lowercase apple, then we'll look at the A. Lowercase a is ASCII code 97. We're going to go to array index 96, and we're going to bump it up. And then we go to the P, which whatever that ASCII character happens to be, we're going to bump up that from 0 to 1. Say we've got one lowercase p, then we're going to bump it up to 2, because the next character is another lowercase p. And then we're going to go to the second string after we finish the first string, and we're going to go character by character through that. And instead of incrementing the associated index in the ASCII table, we're going to decrement.
Where does that comparison?
Every time you decrement, you're going to check if the value at that index is less than 0. If it's less than 0, we immediately return these are not permutations of each other. If we get through the entire second string, then we're going to return, yes, they are permutations of each other. Does that work? The answer is no, it doesn't. But there is one check that you can make that turns the no answer into a yes answer. Can anyone identify what that check is? Yeah.
Are they the same size?
Yes, the strings have to be the same length. And if the strings aren't the same length, they can't be permutations of each other. So before you start, you're going to check, are these strings the same length? If they are the same length, what you end up with is some kind of inverse property where if you finish this entire process, you go through the first string and you increment, and you go through the second string and you decrement. Any value somewhere in that array that is positive has to be offset by something that is negative. Does that intuitively make sense? You have a 4-character string and a 4-character string. We have one fewer of some character in one string. It means there's to be some character that takes its place where there's more of it. So wherever there would be an array index that is above 0, there will be another one that is below 0. That's why we don't ever have to check for anything that is above 0. So the solution is just to do exactly that, check it for the same length. For the first string, go increment. For the second string, go decrement. Every time you decrement, check if we've fallen below 0. If we fall below 0, immediately return false. If we get all the way through the second string, return true. That is a linear time solution to the problem, and it's quite clever. I don't think most people would get that. An n log n solution to this would be perfectly fine. If I'm interviewing people and I get a solution like this, that works. But the person who lands the job would probably get a hint of, I think there is a linear time solution to this. That has to do with storing off character counts. Even if you just got that sense of there's probably a better solution that I could find if I was given more time. Ready for the third and final problem? I'm actually going to use a data structure that we have talked about in this class. All right. This one is less a coding problem and more of a manipulation problem. Describe how you could use a single array to implement 3 stacks. Imagine designing a class that uses a single underlying array list, but has methods to support pushing and popping and peeking to 3 separate stacks.
Array list or?
Either. That is a good one too. More of a history. But
You just have to allow for 3 heads and 3 tails.
how do you do that? Where do the heads start out? What happens when you increment? Or when you push to stack number 2? What happens when you pop from stack number 3?
Probably always need one empty space between all, right? Like a buffer.
Could, maybe. That's the first thing in the pipeline, even though it's not. It is exactly equivalent to this solution. Slightly different. Your solution, is the first thing that occurs to you too.
They both work the same.
Exactly. Yeah,
I think that one might be more visually appealing.
I agree. I see why they chose it, but to me, I'm with you that makes personally the person in my mind as well.
Oh, I guess.
Yeah,
So could you just have it be like list 2 head is equal to list 1 tail dot next? And then list 3 head is list 2 dot tail dot next.
interesting. Where are the heads and tails located in the array?
So the heads are where the first addition, so the first head is always gonna be the first list, first addition. And if that's also the tail of the list, then if you add to a second stack, then it will become the next of the tail, but it would be still the head and the tail.
So what happens if I push to stack 1, push to stack 2, push to stack 3, push to stack 1, push to stack 2, push to stack 3, pop stack 1? Where is stack 1's last element?
That's, it's element number 4.
How are you keeping track of it? If you need to bump back the tail, so if you keep a tail pointer to that and you return what's at the tail, what becomes the new tail? How do you know that it was 3 ago and not 6 ago? And I could have pushed to stack 2, pushed to stack 2, pushed to stack 2, pushed to stack 2. So it doesn't necessarily have to be 3 ago. Good thinking. Okay, so it'd be like moving toward the center. So you have, yeah, one stack moving its toward the center from the left, one moving from toward the center from the right. Yeah, we get a third one somehow. That would be a great 2-stack solution.
That's not how that works. It's not. That was almost better than I
Any ideas? Anyone think they have a solution? 3 stacks, 1 list. This is one of those problems that is deceptively simple. It's just about how you think about the list. And I think that I tried to give this one because I think it shows how much people overthink the problem. Well, we have 1 list.
That wouldn't have been anything.
Where is stack 1? Where is stack 2?
She just looked that way.
Where is stack 3? So you could basically have index 0 here, index that is 1/3 of the length, index that is 2/3 of the length right here, and an index that is the length out here. And now you can build each stack independently from each other. This stack starts here, builds that way, this stack starts here, builds that way, this stack builds that way.
Yes, I was mistaken. That's kind of how I say, is it too simple?
Yes, it's deceptively simple. The other thing that you can do, that was the first thing that occurred to both Hunter and me, is rather than divide the list like this, you can use modular arithmetic and just go by index that is mod 3 equals 0, mod 3 equals 1, and mod 3 equals 2. And that way, the first stack contains indices 0, 3, 6, 9, 12. The second one has indices 1, 4, 7, 10, 13, and the next has 2, 5, 8, 11, 14, etc. Each of these continue. So that would work as well.
If you were trying to access it from that would take you to head node, right? Like you modulus it,
Yeah, so you would store either the size, if it was the size, then you would say something like, all right, there are 10 elements in here. So you would have 10 times 3 plus 0 as the next place to store. And then if you want, there were 10 elements here, where's the next one to go? It's at 10 times 3 plus 1.
Well, I guess it's sort of like you're getting pops.
Yeah.
Most you just do mod whatever it is they had, and you just keep track of the lines.
Yeah, just keep track of the size. So if I wanted to pop from this, then I would go to index 10 times 3 plus 1 minus 3. So this would be minus 2. And then you would go to that index, delete it, remove 1 from the size, and then it would give you the next index to go to, because this 10 comes from that size.
So if you wanted to do
That's
this
true, let's do it.
in three
Oh my
points,
god.
could you have done my solution, except you only add, so if it's the tail, you add it to the tail dot next, and then you check if links list two has the first node. And then you do dot next is equal to that head,
Yeah,
so you
so
can
you
keep
just
it in
change the
order.
fields really to be stack one, stack two, and stack three, and you would have three different lists growing next to each other
Yeah,
as the fields and absolutely, it's so close. It's just a little bit different with an array. So with the last few minutes, I wanted to introduce you to one of the types of challenge problems that you might see. Everything that we've talked about so far in here today has been taking something that you know and thinking about it in terms of solving a problem you haven't seen before, or manipulating a structure that you have seen before to solve a problem.
They're showing the dark side, especially like. We shouldn't have these problems to speak.
This problem is emulate a computer problem. So you're going to implement a function that is the world's simplest function, except I'm gonna outlaw everything that you would want to use. You're going to write except that I'm going to outlaw the use of the following symbols. You cannot use plus, minus, times, divide, or mod.
At all, there is a for error number.
All arithmetic operators are outlawed. This is actually how a computer adds. A computer has no understanding of this. A computer uses something completely different to add numbers. Does anyone know how a computer adds numbers?
Binary arithmetic.
Yeah.
How does it gain access to that without an operator? Is there a command?
You don't add in binary. You still don't add. You use Boolean logic.
Oh, so you can do that shit.
Yes.
Or no.
Yeah, so things that you can use.
I need a piece of paper, it's just so.
What's being stored in here is already in binary.
So
Oh.
it doesn't say effect.
Yep.
Like A and B, if it's both one and then it's five.
Yep. Yeah, you can use binary arithmetic on integers, on the binary representations of those numbers. Yeah. Does anyone know how a computer uses Boolean arithmetic to add numbers? Would hope this was brought up in discrete. If it wasn't, there's no math discrete, it's just CS discrete.
Exactly.
It's not like to use and, that one, it's five, produce the one, it's one, it's zero, one, it's one, one.
Yeah, the only things that you need to use in here are this and this. Those are the two tools that you will need.
What is X one? That's
XOR is the exclusive OR that basically says that it's the same as an OR, except they both can't be true. One or the other, but not both.
the bottom of the ship left one.
Yeah.
Exactly.
Chris, when you're doing the carry, you have to, you can't just bit shift it on its own, right? Cause wouldn't that have some things that like you don't wanna carry over? You have to do like the bit shift of the and or something?
Yeah, you're right. You're right. You do need an and. There is an and gate in there as well. If you're curious, you can look up the solution, or the solution is in cracking the coding interview. I can show it in my office. I don't quite have time since we are out of time.
Is the result of one job, your dedication would be left zero at that spot, right?
Yeah.
And then that's where you, the one, zero.
Yeah. Yep, that's exactly right. It's actually not a 5-line solution. It's quite short and elegant, but of course, if you don't know this is how a computer adds, then this problem would completely throw you for a loop. So just knowing how a computer works, just having that basic understanding of how things are done underneath the hood could save you in an interview. People will do this to really separate those who understand how a computer works from those who have memorized a bunch of things in their classes. I don't necessarily agree with it, but it's common. Good enough to be one of the 190 problems in the book. Yeah. Remember, if you want to see your exams, well, I have these in my office.